I mentioned earlier that I spend a lot of my time in San Francisco, and what I do here is there is inviting people from all over the world to come to this, what I call Candyland, because things work there that wouldn't work anywhere else. To understand what happens in Candyland, what they can translate back when they go into their normal lives. And being invited to curate this conference, I invited 2 speakers to come from Candyland and share their views and thoughts from there. With the tours that I make, there are certain companies where I can only go once a year, and then there are companies where I go every time, because I believe that these are the most inspiring companies, and you should have a conversation with them, understand what they're doing, to take this into your own environment. And one of these companies is called Autodesk. I don't know if you're familiar with the company. They got growth with AutoCAD in the 80s, which is basically an architect software where CAD stands for computer-aided design, if I don't get it wrong, which by the time was totally wrong, but what they're doing today is actually exactly that. And they have the gallery on Market Street in San Francisco where they exhibit products and ideas that have been done by people who use their software. So it's actually not things that they do, but things that they believe their customers doing a brilliant job, and they exhibit this. And when I come there to the tours, it's nice to meet someone from Autodesk to show around and to explain and to understand what happens there. Rama is from Autodesk, and Rama is, for me, I love having this conversation with this woman, because for me, she's a powerhouse, and I like energetic people. But secondly, it's not that she represents a company when she goes somewhere. She really embodies the idea of changing the world to better and working for a company who provides tools and the concept and the way of thinking to change the world to better is a beautiful thing to do. So ladies and gentlemen, please give it up for Rama Dunayevich.
In coming here today, I've been feeling a lot. In coming here today, I've been feeling a lot like Lucy of the Peanuts cartoon, and so it made me excited to be able to talk to you about my point of view of how I see the future and where we're going. And I'm going to start with a quote from the acclaimed French architect Le Corbusier, and thankfully there's not that many French speakers hopefully listening online or in the audience with my pronunciation. But what I think is so exciting about the way that he thinks about the future is that he thinks about having a directive and a rigorous approach to figuring out what the problems are as a way of coming up with what the solutions would be. So rather than seeking a simple solution of where are we going, he says, let's step back, take a look what the problems are, understand the problems, and from there solutions will evolve. And that's what I'm here to talk about today, using design thinking as a way of approaching the future. And when I think about it, there are big problems out in the world, whether it's climate change or the abuse of big data or even the dreaded robot apocalypse. But I have to say, when I go to bed at night and when I wake up in the morning, I still feel unbelievably optimistic about where we're going and where we can go. And part of the reason that I feel so optimistic is that I get to work at Autodesk. And I really believe that it is a place where we design tools and we believe in designing tools to help people imagine, design, and create a better world. And now with the show Silicon Valley, I think that's taken on its own meaning. But we truly believe it, and it's the way we approach everything that we do. Whether you've ever admired a towering skyscraper, or driven a high-performance car, or watched a great movie, you've seen what millions of Autodesk customers around the world are doing with our software. And it's really I tell you this about the company really as a way of expressing who I am and what I feel passionate about. And it feels so good. It's such a gift to be able to work somewhere that so closely aligns with my values and where I feel the future might be, and also to go every day with a sense of optimism and know that it's imbued in the way that we think about the world. Fuel has always acted as an accelerant to our ideas. The coal, when we first thought about coal, right, it was able to bring us from the handmade into the machine-made and kicked off the industrial age. From there, we invented processes for steam and steel, for railway networks and telegraph. And that new data, which is, oh, thank you very much, gas and water supply, and our electrical power, and telephones. And that brought us into the connected age. And as we entered the connected age, it took us those first steps along the way to understand it in that way. And the fuel for the journey now, as the age moving forward, oil. Oil acted as the new accelerant to our ideas and where we were going. Does this sound familiar, the oil boom and how it was unregulated and everything there was a tremendous desire to figure out where it was going to take us. And there's a new fuel for making our ideas real, and that new fuel is data. Data is the fuel that is driving the new economy. And the cloud, without taking the metaphor too far, is its pipeline. The 5 largest companies in the world, Google, Amazon, Apple, Microsoft, I always forget one, Facebook, is transforming the way all of us live, the way we travel, the way we communicate, the way we relax. No longer do what we do have to sit confined on a computer desktop, on or underneath a computer. And no longer do our static designs of what we've put together need to sit and have no movement. Now the tools, what we make and the products that you make and the tools that we design continue to evolve. It's a new connected age where nothing that we make ends at that point. It continues to live out into the world. And that idea that our data is constantly transforming and moving out into the world can be somewhat threatening. But we've taken these tools and that idea of data constantly creating into a new paradigm of thinking about design, and that's called generative design. In the old days, we had a tool, and the tool would say the mouse, and the mouse was directive, and you said, okay, this is what I want to do, and you would move the tool to make that possible. Or you would push it down and you say, okay, this is what I want to do, and I was all outgoing. This is my idea, and I'm going to push it out into the world. But with generative design, we flip that on its head. So no longer are you just thinking about what the design is while you're designing, or simulating what the design would be when it's going, but actually coming up with new designs that you never would have come up with on your own. Because the computer now is able to intuit what you want. You give it in the same way that Le Corbusier said you should go back and think about your problems. Now you put in the stresses and the object of what you want to create, and the computer will create millions of designs for you and create something you never would have come up with on its own. And again, I think that's a threatening idea, that now the designer is working in tandem with the computer, and the computer is taking that design into the world. But it really is opening up our minds to a completely new way of thinking of design. Autodesk has an office in Toronto, and we recently moved into a new office and used generative design as an experiment to think about things that are much more important than simple geometry, like the chair, but to think about the needs of people. And this is a vision of our new headquarters, and we're using it as a living experiment. In the same way that we fed in the geometry of what we needed for the chair, we fed into the geometry of what we would need. What do people need? How do we create a space that has greater access to light and that takes into consideration that these are the 4 walls of the building, and this is where the kitchen needs to be because of the plumbing, and this is where the bathroom needs to be? And we fed all those parameters into the computer. And we surveyed our 250 employees that live in Toronto, and we asked them what they wanted. And then the computer generated a floor plan. But not just one floor plan, thousands of floor plans. And from that, we could take the vision of what the computer had done in conjunction with the people that it was working with to create a new space that was more efficient, that was more comfortable, and that was a better place to work. So rather than being directive in the same way that we were with the mouse, where we said, okay, this is what we're going to do, the system now could become adaptive. And that same idea of transforming the way that we think and where we're going can be brought into robots. And I think a lot of people are quite afraid, and potentially for good reason, of the robot apocalypse. And actually, the way that we make things is transforming. And we no longer have to keep our robots locked in one place and have a data-driven design of how we're going to make things more efficient. Because in the past, we had to think about the economics of robots, and we put them somewhere. They're enormous, right? And a robot could knock you out in a second. So we had to lock it down, and we had to keep it in one place, and because it couldn't see who we are, and it couldn't see where we were, and it's dangerous. So we thought about a new way of thinking about robotics, rather than locking it down in one place. This is our robotics lab in San Francisco, and in it we have a computer named Ash. And Ash is not like the robots that you saw just previously. We don't control what she does. We let her control what she's doing. This is Ash, and she is actually 3D printing in metal, in real time, on her own. She stops, she corrects, and she keeps going. This is completely different from the old way of thinking about robots. In the past, if a robot was doing an activity, it would keep doing it, even if it wasn't in place. So if there was a mistake, it would continually just keep doing it. Now, with computer vision and new data and being able to feed that into the system, she's able to print on her own. We've taken that a step further now and brought computers into virtual reality. So now we can interact with her and change the way that we work with robots, so that you put on the glasses, she sees the space, and now you're collaborating one-on-one with a massive couple thousand-pound computer. And with our own hands, we're able to direct the way she uses her hands, or in this case, hand. So again, the idea is that she's no longer directive and rigid. We're not telling her exactly what to do. She's not locked down in one place. The whole system of communicating with the computer is becoming much more adaptive and fluid and collaborative. When we designed this chair with generative design, it took the idea of geometry and worked on the chair. And when we thought about the building, we took the constraints of the building, and then the building was in a better place. And now we're starting to work with moving systems. So this chassis took the idea of generative design and created something that we censored quite a bit, so that as it came back and forth, we could understand what would happen and what were the forces directing a moving object like a car chassis. But one of the problems with that is that data and the advances of computers have become so great that we could understand what was happening and we could hold it in our hands, but we could no longer hold it in our heads. And it's become inscrutable. And that's a problem that is threatening. But with machine learning and the parallelism of computing, where we can create so much more data and communicate so much more greatly, machine learning has actually accelerated what we're able to do as people. So I think I'll take an example of something that I think a lot of people use, and that's Google Translate. In the past, Google Translate would come up with a translation like this, and it didn't make any sense. It was doing exactly what you do when you go to a country that you don't know, and you'd say, okay, I know that tree in German is Baum, but I can't make a sentence with that. And so now they've fed that into machine learning, and now when Google does a translation, it is much closer. It captures the nuance of what we believe and what we want to say. But there is a downside. It's inscrutable. Very few of us understand what is going into Google Translate and making it understandable. We're locking this new data in a black box, and that's threatening. But just because it's inscrutable and not inspectable doesn't make it any less trustworthy. In fact, machines are better than we are at facial recognition, at cancer detection, and at driving. In the past, with self-driving cars, it's no longer an if-then statement. The development of self-driving cars is now becoming much more creative. It is the process Again, back to Le Corbusier, instead of just thinking about the solution of that the car needs to get from A to B, we have to start analyzing and provide analysis and use machine learning to understand what is the circumstance around which self-driving cars are driving. Rather than looking backwards in the rearview mirror, we can now look forward and think about the condition of what's happening, and the computer can be insightful about what we might want to do. I'm going to go back to robotic systems. I like robots. And talk a little bit more about how we're now working with robots to make things happen. So as you can see, this is a fine artist named Madeleine Gannon, and she now has developed a system where she can work with the computer in tandem. As you can see, I mean, that's thousands of pounds. If it makes a wrong step, she won't live to talk about the work that she's been doing and continue to work. So we have this new computer actually called Bishop, and we introduced him to the very disorderly world of Lego. And Bishop now can understand, he can actually see and understand the environment that he's in, and that he has a hand to pick up Lego products and he can move them. And he's developing a system for which to do that and his entire environment. So that when he sees this messy pile of Lego, he can say, well, the piece that I need is red, and it's turned sideways, and I need to turn it over in order to make it fit. This is a huge leap forward for computers. In the past, it would just be, okay, this is what they're doing, and this is what they're doing, and this is what they're doing. And so by giving him this simulation and explaining to him what's happening in the background and simulating the environment that he's working, he's able to process those ideas and make them a reality. And he's able to do it in a way that, unfortunately, as humans, we wouldn't be able to do. We don't have that capacity. And he takes one, and he turns it, and he takes one to turn it, but he's doing it in computer time. So rather than just doing one at a time, one at a time, one at a time, he's able to accelerate it and make the system better and better and better so that there are millions of options. And one of the amazing things about that is that because of the cloud, it's not that just Bishop understands it. Now, because data is shared in the cloud, all computers and robots can understand it. So it's communicating the ideas across. So again, the idea is that we're not being confined to the rigid places that we've been in the past with technology, but we're able to see it through and be adaptive. So just as we had to let go of the steering wheel to think about self-driving cars, we need to let go of the idea that we're going to control everything that our computers do. We can no longer think about computing as something that's locked in a black box on your desk and be so directive. We need to the cloud needs to make us change the way that we think and the way that we make our tools so that you can change the way you think and the way that you create. The computer is now, and the way that we're working is becoming adaptive and fluid and no longer these kind of tight, rigid ways of thinking as we have done in the past. And now it has become a collaboration, so it's not just that black box that you don't understand that's inscrutable. It's actually a relationship that you have with your computer so that it doesn't just understand what you want, but it can understand your ideas. And so together, we're going to be able to create an incredible world where the computer is not just defining who we are, but is working together with us. And together, we can all make a greater world.